Notice we have three different limits. Two of them are two-sided, one of them is a one-sided limit. However, notice that they are missing variables, so all we have is a constant number. If we were to look at the actual graph of this, you would see that this is a graph of a horizontal line at the 3, at y equal to 3. So what happens is that our limit is 3. It doesn't matter from where we're approaching it. It's going to be that constant number. Same thing here. We're approaching part B from negative. We're approaching it from -4 from the left and the right. It doesn't matter because it's constant. It's going to be 5. And then for this last one, even though it's a one-sided limit, it doesn't matter because we're still approaching that same number regardless of how you look at it. If you're not sure about this, feel free to look at the graphs of these. If you were to graph, for example, this graph, you would graph in your calculator y is equal to 3, and that's simply a graph at 3.
Could you say that again, please?
That goes all the way across. Problem 9, we're going to go ahead and do some algebra here. And there's various techniques that you're going to just have to be comfortable with. You will need to be pretty algebra savvy for this, very algebraically comfortable with doing some of these things. So the first technique that I want to show you is, well, notice first of all, if I were to, that usually the reason why we do limits is because there is an undefined singularity somewhere, right? But notice that this time, as x approaches 1, that if I were to put a 1 in the denominator, it would not result in division by 0. In other words, it would not be undefined. So I'm going to use a substitution for this problem. I'm going to go ahead and actually substitute 1 into every value for x. And if I do this, it simplifies to 1 plus 1 plus 2 over 2, which gives me a value of 2. So this limit as x approaches 1 for this function is going to be 2. Okay, and again, we were allowed to do that. Of course, you're always allowed to do that, but if the denominator becomes 0, that becomes an issue. In this case, that wasn't an issue at all. When we look at part B, the same thing. Notice that there's no denominator here, so if I were to plug in a 0, it would not affect us in negatively in such a way that we get an undefined. So I'm going to go ahead and substitute once again. And in this case, part B has a limit that is equal to 2. Part C, same thing again. We can substitute. I would commend you to go ahead and substitute. You should get an answer.
I'm going to ask you a bunch of questions.
Check it out for yourself.
And have them answered immediately.
In part D, we ran out of luck. If I were to plug in a 1 in here, it would result in an undefined in the bottom. So, what do? Well, I'm going to suggest that you factor. The numerator is a difference of squares. If you're not sure what a difference of squares is, you will have to go ahead and review that on your own.
That's all there is to it.
I'm going to be a bad guy and be a pre-calculus teacher and say you should know how to do that by now. If not, you have the time to go check it out. So if I go ahead and do a difference of squares here, you'll notice that these two binomials cancel out. All I have to worry about now is a limit as x approaches 1 of x plus 1.
Perfect.
Which allows me to put the number in here, substitution, and I get an answer of 2.
You win.
As much as we'd like to go ahead and substitute, it would be undefined. As much as we wish we could do a difference of squares, we can't because this is a sum of squares. So for this one, we would have to relegate ourselves to either using a graph, as we've shown you how to use, or use a table in a calculator. I leave that as an exercise to you. Nevertheless, one side of the limit approaches infinity, the other one approaches negative infinity, and so you should get a D and E does not exist. Please confirm, check, pause the video, try this problem out, confirm that this is true.
I want to have them answered immediately.
F with the trigonometric function. If we were to substitute for this problem, this actually works out nicely. Okay, so I can plug in a 0. Remember, make sure that you're in radian mode, and sine of 0 is going to be 0.
Perfect.
Once again, if I plug in a -3 in for this, I get an undefined in the denominator. So substituting doesn't work out. And we don't have a difference of squares. However, we definitely can factor the numerator, as it is a polynomial trinomial. We did slightly review factoring when we did exponential modeling, and if you're still weak at that, you need to review that because you are not worthy or fit for calculus if you cannot factor these quickly. Just being dead honest with y'all. So if you're wondering where this came from, pause the video, go review. Okay? Alright, so what we have here is a nice little setup where these two binomials cancel out. So we get a setup almost like the one from before with the difference of squares. And then if I were to go ahead and notice, directly substitute in this for the x value, I get a limit of -5. For h, believe it or not, there are ways to do this, right? For example, you could say tangent of x is sine x over cosine x. Don't write this down, please. Stop writing this down. Don't write this down. And then you can go ahead and separate these and say this is sine x over x times 1 over cosine x. And then you can recall that earlier in, I think, problem 2 or problem 3 in these notes, we talked about what limit of x approaches 0 sine x over x is. And you can use that value and then do a new one by substituting x for cosine. And then I think that is way too much. A lot of people, teachers, professors, textbooks, if you Google it, you'll probably see something crazy like that. That is such a waste of our lives. You can either use a graph, or many of you are very adept at using the table. I'm all about the philosophy that math should be done the easiest, fastest, most efficient way. And for part H, the most efficient way would be to use a table, in my opinion. Okay, so take a moment, pause me, use a table, but you should be able to find that the limit of this thing is 1. Okay. Finally, on our last one, again, notice that it's no big deal if I plug in a 0 in here, although it'll make everything 0. The problem is in putting 0 in the bottom right here. This becomes undefined. Okay, and again, limits allow us to make predictions when things are undefined, which we don't know how they're going to work out. So may I suggest for this problem, what if we go ahead and distribute the x? That's what we get, right? Because you have x times 1 is x, and if you have x times 1 over x, which some of you might be hurting a bit, you'll notice that the x's cancel out, and you have a 1 left over. Okay? So, doing that, we plug in the 0, and whoop-de-doo.
Hello there.
We get a -1 for that one as well. Okay, so just be aware. Use all your algebra skills that you've picked up and learned at some point. They will serve you well. For your summary, what are some indicators or hints of when certain techniques can be used?
You win.